Hello everyone. So in this video, we are going to talk about the TFX component for model analysis and validation. And we'll be looking at the evaluator and then the resolver node. So what are these two nodes for? So before we talk about this node, I want to talk about model analysis and validation. So after training your model, you want to validate your model. So does your model perform well across all metrics of interest? And this is also a good component. For example, if you have a model which has different fields or different features, for example, your problem is to predict salaries of workers in the US. So for such a data set, you would have people across different categories, across race, across education. So maybe you would like to see if your model does well predicting people, the salary of people who have gone to college um, compared to people who have not gone to college, or does your model do a better job at predicting the salary of black people than the salary of white people? So you usually do model analysis and validation to check for model bias and things like that. In our data set, we just have the review and the rating. So we are not going to perform slicing. We can't do slicing of the data to see if the model has bias or not because we don't have other information. If our data was put into categories, for example, reviews of maybe horror movies or review of drama or reviews of trailers and things like that, then we could check for bias. But this is just a simple model. So we would look further into details for model analysis and validation in our next playlist when we talk about deploying pipelines in the cloud. So for now, let's go ahead and then look at the components we are going to use. So the first one is the evaluator component. So let's go to the documentation, and it says that the evaluator component performs deep analysis on training results for your model. So it helps you to understand subsets of data like I talked about. And it also helps you to validate your model, ensuring that they are good enough. So you can set a threshold that if your model's maybe accuracy is above 50%, then your model is good enough to be pushed to production. You can also use the evaluator component to compare two models, because our goal of building a pipeline is not to just build a pipeline and run it once. We want to build a pipeline and run it multiple times over the course of maybe our problem. So when you build a new model, you would like to compare to the old one. Does the new model's accuracy is it better than the old model? If it's better than the old model, then you say that your new model is now your good model, or we call it's now your blessed model. So yeah, the evaluator component makes it easy to do things like that. You don't have to track the accuracy manually and see which model is better than which one. You can just use the evaluator component just to make your life easier. So let's go ahead and then use the evaluator component in our work. So I'll go back to my tab, and then the first thing we are going to do is actually not to call the evaluator component, but to actually use the resolver node. So the resolver node is the node that will keep track of your blessed model, or the model that performs best, right? Okay, so what we will do first is to first call our resolver node. So first, let me just create a header here. So we'll call it resolver, and then make it a markdown. And then I will say from tfx.dsl. Now the resolver node is not in the same component directory as the TFX component. is a special type of model, so it's somewhere else. Dot resolver, import resolver, and then we are going to import a strategy called latest blessed model strategy. And so that will be from tfx.dsl dot input resolution dot strategies dot latest blessed model strategy. I feel most of these names are too long, and the TFX team can do something about this, but yeah. Then from TFX dot types import channel, and then from TFX dot types dot standard artifacts import model and model blessing. So the standard artifacts points to the directory of some directory. So the model artifact points to the directory of our training models, right? So if we provide that to our resolver node, we don't really have to use the output of the trainer component. The model artifact will just, when we pass it to context, it already knows where those directories are. So say model resolver, and then we say resolver. Our strategy, so our strategy class, we'll have our strategy class is that, and then we have our model, which is the channel, and then of type model, and then we have model blessing, which is channel of type model blessing, and then we have an ID. So we can provide IDs for all our components, but I usually just provide an ID with the latest blessed model, latest blessed model resolver, right? And then we will just, as you guess, context.run model resolver, right? So when we run this, so no errors. So let's go ahead and then now use the evaluator. So as I said, the resolver node will keep track of your latest blessed model, and you see more into details what that means. So before we use our evaluator, we have to specify a configuration, right? So configuration involves what metrics you are tracking. So your AUC, your false positives, your true positive, your false negatives, your true negatives, your binary accuracy, things like that. So what kinds of metrics are you tracking? And then also you can also set a threshold. As I said, you would like to compare your models with your new models with your previous models, or you would like to set a model like standard, or the let's say your baseline model, right? So how good should your model performance be? So for example, I can say my binary accuracy has to be 50% or above, or above 50% in order to be called a good model, right? And then if I train a model which is 0.001 more, which has 0.001 more accuracy than my old model, then that new model should be my latest good model, right? Something like that. So we can put those logic into it. And Evaluator uses TensorFlow model analysis under the hood. So I said we will go into details in TensorFlow model analysis in some other playlist. And then before, okay, so let's go ahead and then just I'm just going to create another evaluator. All right, so I'm just going to run that markdown, right? And so the first thing is I'm going to import TFMA. So import TensorFlow model analysis as TFMA. And then the next thing we will do is to specify our configuration, right? So I will say eval config. So TFMA dot eval config, and then the first thing we will specify is something called model specifications. So your model specifications include something like your label key, right? So let's go ahead and we have to specify what our label key is. So model specs, and then we have TFMA dot model spec label key. So our label key is called what? Rating, right? Then the next thing we will specify is our slicing specs. So as I said, if your data has different fields or different groups of people or objects or something like that, and you would like to see how your model is performing, to see if your model is biased towards predicting, doing predictions for a certain group, then you'd have to slice your data and see. But in our case, we don't have any specific group or anything. We didn't specify anything like that. So our slicing is going to be left empty, which means that include all the data and perform these metrics over all the data. So, and then we have our metric specs. So metric specs is where we will specify all our metrics. So here too, we say TFMA dot metric spec, and then we have our metrics. So the first metric is TFMA dot metric config, and then a class name of example count, right? So let me go back to the evaluator. So there are a whole lot of I think if you somewhere you'll find all the metrics that you can add to. You have to look somewhere in the documentation. You find all the metrics that you can use in TFMA. So let's go ahead. So I'm going to do example count, and I'm going to do TFMA dot metric config. I'm going to do area under the curve, and then I'm gonna do TFMA dot metric config. I'm going to do false positives. I'm just gonna do false positives. Yes, just this one, so you can have true positives, false negatives, and all that. And then the next one I'm going to do is the binary accuracy. TFMA dot metric config, and then class name, binary accuracy. All right, so what do we want to use our binary accuracy for? So as I said, you'd like to compare to see if your model performs better than your old model, or if your first model that you trained has the threshold to be your baseline model, right? So we are going to set some thresholds, right? we're going to set some threshold. So we say threshold, so TFMA dot metric threshold, and then we'll say this one should have a value threshold, and that should be TFMA dot generic value threshold. And then we say that if the threshold has a lower bound of some value, so we're going to say value of 0.5. If it has a lower bound of 0.5, then we can say it's a good baseline model. And also, if our latest model that we trained, so I'm going to say change threshold. So if the new model that we trained is above a certain threshold, also take that model as our latest good model. So we say direction. Direction is very important to specify because here we are using binary accuracy. So if the direction is higher, then we say it's good, right? If you're using something up like loss, so if it's loss, then if the direction is lower, then that is good. But here, so TFMA dot metric direction dot, so here we'll say higher is better, and then we have the absolute. So what should be the absolute value? So the value should be 0.001. So if the new model accuracy is 0.001 higher than the old one, then we say, oh yeah, we have a good model that we can use. All right, so is there anything else? So let's say, so we just called here an evaluator component and then pass this configuration to it. So from tfx.component import evaluator, and then we say evaluator should be equal to evaluator. Here we pass example, so it will be example gen outputs examples, and then we have model, that will be trainer dot outputs model, and then we have baseline model, which is model resolver dot outputs model, and then we have eval config, which is our eval config, right? So as you can see, we are specifying baseline model, but we don't, this is the first time we are running it. We don't have a baseline model. So your baseline model is the first model, right? And then after that, every other subsequent model will be compared to that. So context.run evaluator. So enable cache. Okay, I'm not gonna enable any cache. So yeah. So yeah, let's see if this runs. So let me just watch it for, before I pause the video, I'm just gonna watch it for a couple of minutes, and then yeah, if I get a lot of warnings, then it means that it's running. All right, so it's running now. So I'm just gonna pause this video and then come back when it's done running. Okay, so it has finished running without any errors. So how do we use this? So I have written some code snippets that will help us to visualize this. So we are going to use TFMA view to render our visualization. So here I'm just passing the output of the evaluator, the artifact URI to evaluator results, and then I'll use TFMA.load eval results to load the evaluation results, and then I'll render it with TFMA.view render slicing. And then we can also have a fairness widget that will view the TFMA results, and then you'll see the output of what this does. And then you can also print the validation results. So when you print the validation results, it tells you whether the model passed our threshold checks or not, right? Yeah. So let's go ahead and then run this. Anyway, when you copy this into your cells, you may need to run it more than once for it to run. There is some sort of glitch. And also, sometimes it may not run at all. So if it doesn't run at all, you may have to run these commands to cause it to run. And if they say you don't have NB extension installed, you would have to install it with pip, or if you are using Anaconda, you have to use Conda. You can just Google online how to install NB extension. It's very simple. Yeah, so you can just do pip install something, or yeah. So yeah, so NB extension is just a way. I think it's a Python model or something, and yeah, it's what I use to create this table of contents and stuff. So as you have it here, I installed it long ago. So yeah, you can just check online how to install NB extensions, and you'll find a link to that. So let's go ahead and then, so go ahead, copy this in your cell, and then let's run it. So if you run it, so for the first one, so we can see all our metrics here. So we can see all our AUC, our binary accuracy, our example counts, our false positives, and then our loss. So what happens if I click this one also? So for this, so it's similar to this, just that this gives you a nicer view. And also, yeah, so this one I can select my binary accuracy, my example count, and all that. Also for this, if we had some slices of data, we could compare them. So I can select my binary accuracy and then see what yeah, so some pop-ups are here. Yeah, so you can see what all these stuff give us. So let's go ahead and then print our evaluation results. So you can see validation okay. So validation okay means that our model has been blessed because it passed the check. We can go into our model directory and then see our pipeline. We see that our evaluator folder has been created for us. We have blessing over here. We have 9, so blessed. So this shows our model 9, so which was our model. So if you go to trainer model, not necessarily. So let me see here, pipeline, evaluator, evaluation, blessing 9. Oh no, yeah, we haven't pushed it yet, so we can't see the which model gets pushed. So we will look at pushing the model to, I was looking for the pushed model, but I realized we haven't used the TFX pusher component yet, so we can't see which model was blessed. So even though we know it's our latest model, but yeah, so let's go ahead, and then in our next video we would use the TFX pusher component. So see you in the next video.